Hello, this is Miss Dagan Ford again, and I wanted to help those of you who may be missing Friday's class or just want a refresher on the olfactory sense and the sense of taste. Now this is going to go pretty fast. We're not going to be able to spend too much time on it, but I wanted to get as deeply as I can to the cellular response. How does our sense of smell work? Now, this does correspond to one of our worksheets. We took some notes on this, but we're going to also just in a much nicer way, we're going to elaborate on it. So, olfactory and taste. Now, first, let's go over where this is. So, here's our person's face, and we've got our forehead, and think about what happens below that. We've got our skull, and the skull is coming down, and we've got the person's eyes roughly here, and the smell, of course, is coming up through the nostrils. And the nasal cavity is going to be at the top of our, the olfactory receptors are going to be top of the bony cavity there. And it's this little area, this little patch, and it's got it's actually a yellow color, and it's about 2 centimeters squared. I like to think if you have the 2 pads of your fingers, it's roughly that size, almost like a postage stamp. For animals that have a much better sense of smell, this is going to be much larger. Now, if you have these olfactory sensors, they do have to go through the brain, through the skull, and they go through these little holes, the neurons, and then they go to the brain that's sitting right there. So olfaction is kind of right behind the forehead. That's how we interpret the sense of smell. So what do these guys look like? Well, these receptors on the top of that nose. So when you smell, think about when you inhale what you want to smell. You walk into the dining hall, and oh, they made pizza, and you breathe deeply, and you bring those odorant molecules, which are basically parts of what you're smelling. It's something that you're bringing into the nose. It's physical, and you are inhaling it up to the top of your nose. So these little receptors, and they're epithelial cells, and they have these little cilia projecting. Now, your book will say things like hair-like. So these are the receptors. Now, just please don't call them hairs. They are not hairs. So these are not your nose hairs. They're cilia that are on the top of your nasal cavity. So they're kind of sitting right here, these little cells. And so as you breathe in, you're breathing in those molecules. Now let's magnify those receptors. So I'm going to end with 1, the bottom of 1, and then we've got these little these cilia that are sticking out from them. And then I'm going to magnify that cilia one more time. We're going to look at the cilia. Now the cilia, along its membrane, we're going to have little receptors. And these receptors, and I will zoom in on these in just a second. So these receptors have a very specific shape. And so these receptors going to sit along the membrane of these cilia that are on these cells. And here's the key. Let me zoom in on that a little bit. There we go. So here's the key. You're bringing up, let's say it's pizza day, and you're breathing up that smell of that pizza. Now that means that there are physical components, there are chemicals that you're bringing in. Just for the sake of argument, we're just going to use little dots. So this could be the oregano on the pizza, this could be the cheese sauce, whatever you want to call it. So they're going to actually be floating up. Now I drew those way out of proportion, but they're going to be floating up, and as they make contact with the receptors, those receptors are going to send a signal. It's going to start a signal, and it's going to be converted to a nerve signal, an action potential that goes to your brain. Now, as little as we're going to go over it, this is actually quite crazy, because your olfactory genes, we have over 1,000 of these guys. So they are still important. um, for our survival. In fact, more so than we think. Think about all of the billions of dollars spent on the perfume and cologne and antiperspirant and soaps, and we like smells, right? And the cheese tastings and wine tastings and chocolate and how wonderful that is for us. So we have all of these receptors. Now each receptor is going to be a different shape. So if I could real quickly, let me get down to the smallest. There we go. So the receptor on one cilia could be a different shape on another cilia, and then another cilia could have this shape, and each shape corresponds to a different odorant molecule. It could be your wet dog that you're smelling. It could be the perfume that you just bought and oh, it smells so good, or the cologne and you spray it all over the place. Oh, it smells so great. So each receptor has a different shape that correlates. Now this is not perfectly it doesn't have perfect fidelity. Some molecules can fit more than one receptor, and then some receptor can fit more than one odorant molecules. And it's that complication that allows us to mix and match and detect those amazing number of smells that we can detect. But it's this type of interaction between the shape of the receptor and the shape of the odorant molecule that comes and binds, which then causes us to uh, get that signal to our brain. And then our brain can combine all of the different receptors. So while we may think, ooh, pizza, what your brain is kind of doing is converting the oregano and the cheese and the basil and the tomato sauce and the crust and kind of putting all of that together for a recognition of, oh, it's pizza day, yay. Or crab soup day, yum, and you're putting all of that together to be able to detect a memory of a food. And just to show you or remind you how powerful that is, just think, if you ever got sick after eating something, your brain remembers how bad that was, and you will physically have a response to that. And you will oftentimes not be able to eat that food after you've gotten sick, and that smell has a lot to do with it. Now, taste works on a very similar fashion. It doesn't have the variability that olfactory sense does. In fact, you might remember that there are four tastes. There's actually five. There's, of course, sweet, there's salty, there's sour, there's bitter, and then there is a new one that they've discovered almost like a decade ago, a little bit longer than that, called umami. Sweet will detect glucose. That makes sense. And derivatives of glucose. Salty is going to detect sodium. Sour detects acids. Bitter is going to detect things that have alkaloids or they are basic. Think of the pill or bitter chocolate, dark chocolate. You can think of that. And then umami is a fascinating one. It detects things that are kind of savory, and it'll detect glutamate. And that is often an amino acid found in meats and mushrooms, even some vegetables. Your tongue will taste it as savory. We like that. If you've ever watched cooking shows, they really elaborate on that taste that makes us really kind of dig in and realize that it has a depth of flavor to it. But it does operate in a similar fashion. The shape of those molecules, the receptors detect. Now, that makes you hopefully ponder that in reality, what we are tasting is really more what we're smelling. So, your taste buds, if you've ever noticed, if you've gotten really, really congested with allergies, with sinus infection, if you've ever noticed that your taste is off, well, your taste isn't really off, your sense of smell is. You might actually still be able to taste the salt and the sweet, but because you're not smelling what you're tasting, then your brain is confused and you just think, oh, it doesn't taste as good or it tastes different. When you taste things, you're often bringing up that aroma unwittingly. You're breathing it in up into your nasal cavity. And if you've ever watched people with wine tasting or cheese tasting, they kind of inhale or sniff, and they bring that bouquet of the wine up into their nasal cavity, and as well as tasting. They do some really funny looking things to detect that, but they're bringing up all of those odorant molecules of the wine. They're bringing it up into their nasal cavity, as well as letting it sit on their tongue, and for them to interpret what the tastes are. That's actually all we're really going to do with a taste of smell and olfactory sense for right now. So that definitely should get you caught up. Have a lovely day.